Hello and welcome to our video on the square transformation. Now we've previously looked at the circle of transformations and how we can take curved lines or data that makes a curved line and transform it into a straight line so we can perform a regression analysis and get a least squares regression line from our data. We're going to be looking at the square transformation and how to use your CAS to do that in this video. And that will be anything with a squared on it. So it's x squared or y squared. So we've got both of these here. And there's nothing in this one here. So it's going to be one of these three quadrants. Here's an example of some data. And this data looks like this quadrant here. So we would use the x squared transformation for it. The square transformation is a stretching transformation. This is worth noting down because you might be asked what it actually does. It works by stretching out the data points at the far right hand side of the scale on the x-axis or the y-axis. So it's going to take these points and move them over here, stretch them out, so that we end up with our points making more of a straight line. So these ones will stay about the same. And then the further to the right we go, the more spread out they'll be, so we end up with a straight line looking something like this. Got a diagram of that here. So the x squared transformation spreads out the higher x values relative to the lower x values, leaving the y values unchanged. So here's your original data, and here's where it's pushing it across to put it into a straight line. The blue is the original data. The y squared transformation works in a similar manner, but it stretches out the scale on the y-axis. So it's going to go up or down for high values of y. Here's an example of a question you might get. The scatterplot opposite was constructed from the data in the table below. Here's the scatterplot. From the scatterplot, the association between y and x is nonlinear. Hopefully you can see that it's a curve. Linearize, that's the word we use when we're asking you to transform data. Linearize the scatterplot by applying an x squared, so they're telling you which one they want you to use. An x squared transformation, that means this, and fit a least squares regression line to the transformed data. If you weren't told which one to use, you would need to use your circle of transformations, and note that it's going like this, which would be similar to this graph here, and you would choose one of these three. Because we're doing the squared transformation in this video, I would choose x squared, and it says to use x squared in the question anyway. The next step is to open up your CAS and enter these data points into your statistics application. So we're going to use the statistics app, and I'm going to scroll along to find a spare column. And I'm going to use X and Y for my headings, and I've already put in my data points. You might like to pause and take a minute to enter the data points into your CAS. Pause the video now. Okay, our first step always when we're using this data is to draw a scatter plot and make sure our scatter plot looks similar to the one in the question. So we need to click the Set Graph button, choose Scatter, choose X for your X values and Y for your Y values. Click Set, and then we need to press the Graph button to show us the scatter plot. And this looks very similar to the one that was in the question, so we know we've put the data in correctly. Now we're going to be performing an x squared transformation, so we're going to need a third column here, which we will call x square with a u in square. something like that. And we're going to use the calculate section of the CAS to help us calculate here. And in the calculation area, we need to type whatever the name of our variable is here. Ours is x. And then we use the power button, which is here, and make it to the power 2. Now, if this variable was called height or weight, you would write height to the power 2, or weight to the power 2. Ours is just called x, so it's a bit easier at the moment, but you need to make sure you can do it with other variable names as well. Click EXC once you have done that, and it will automatically square the values. What it's doing is taking these x values and squaring them. So 1 squared is 1, 2 squared is 4, all the way to 5 squared is 25. What we need to do now is create another scatter plot, which is hopefully more closer to a straight line. So this time we're going to use the x squared for the horizontal axis, and the y still stays the same. So we go back to set graph. For our x list, we're using x squared this time. There it is. Keep our y the same. Click set. And to see the scatter graph, click scatter graph. You can see our data has linearized. It looks a lot more like a straight line now. You can now go on to find a least squares regression line, which you would do by going to calculate, regression, linear regression, and you need to put the x and the y list in again. So the x was x squared, the y was just y. If you want to copy the formula, if you need to copy the residuals, you know how to do that. Click OK. Make sure you've got the right linear regression selected, and it tells you the value of A and the value of B that you can copy down to put into your linear regression equation. Click OK and your regression line will show up, and you can copy out to answer the question here. The equation of the regression line was y equals 1 plus 2x. You can also perform a square transformation on the y values. So a y squared, this one here is y squared, and this one here has the option of y squared as well as x squared. You would use exactly the same method, but at the start when we did x square here in the third column, instead of that you would do y square and put a y in here, and then you need to, instead of using this y, you use this y column and keep the x column. So make sure you know how to do both ways with the two square transformations. Thanks for watching the video.